Find all set of 2-digit numbers such that once the original 2-digit number and the number found by swapping its digits are added, then the result is a perfect square. This is the problem which we are going to solve it in our today's lecture. That is that set of 2-digit numbers such that the original 2-digit number and the number found by swapping its digits are added, the result is a perfect square. So let the original number be x1, which is equal to 10a plus b. That is, this a and b, they are digits, that is from 0 to 9 inclusive. Let the original number be 10a plus b. Therefore the new number with swapped digits of the original is x2, which is equal to 10b plus a. That is, if the original number is 10a plus b, then the swapped number is 10b plus a, and thus the sum becomes the two numbers added together. The first number 10a plus b added to 10b plus a, and the original number x1 10a plus b and 10b plus a, they are both added, then it becomes 10a plus a is 11a and b plus 10b is 11b. That is the sum s, 11a plus 11b. And this sum could be factored as taking 11 out common, 11 into a plus b, and a and b are digits in the range from 0 to 9 inclusive. That is, we took 11 out from sum 11a plus 11b, and it becomes 11 into a plus b, a and b are in the range 0 to 9 inclusive. Now for this factor, that is particular factor a plus b, it has to be of the form of 11n squared. Why only 11n squared? Because for the sum has to be a perfect square, one factor of 11 has to be in a plus b, since there is already one factor of 11, and the other factor of 11, that is 11 into 11, shall make it 11 squared, and n squared is already there, basically means that shall become 11n whole squared. Let me repeat it, that a plus b is 11n squared if and if only if then it is substituted into 11 times 11n squared. 11 11 11 squared, and n squared means 11n whole squared. Now for different values of n, these are integer values 1 2 3, the factor a plus b could take on the form 11n squared, which is equal to 11 into 1 squared, 11 into 2 squared, 11 into 3 squared, and so on and so forth. That is 11 into 1 squared, 11 into 2 squared, 11 into 3 squared, and so on and so forth. Now let's compute these values. I hope you will be mature enough to understand the fact that this actually becomes, that is 11 into 1 squared, this actually becomes 11. 11 into 2 squared, this becomes 44. And 11 into 3 squared, this becomes 99. That is 11 times 9, which is equal to 99. And so on and so forth. Now for the value a plus b, that is which is the sum of two digits, it is in the range of 0, that is the smallest sum of two digits 0 plus 0, till the largest sum of two digits 9 plus 9 18. And only for n is equal to 1, that is only for n is equal to 1, this 11n square becomes 11. And this is the only value 11 which is greater than or equal to 0, lesser than or equal to 18, which is in this valid range. That is, for only n is equal to 1, the very first integer 11n square has a value 11, which is in this valid range. So now we got to find out those digits, those single digits, to sum up to 11. And starting from the very first digit, which could be summed up to another digit to get 11, that is 2. I did not take 1 because otherwise I would have been coerced into adding it to 10 to make it 11. But 10 is a 2-digit number. 2 plus 9 is 11. Increment this on this side by 1, decrement on this side by 1. 3 plus 8 is 11. 4 plus 7 is 11. 5 plus 6, 6 plus 5, 7 plus 4, 8 plus 3, and 9 plus 2. They are all 11. So for this particular condition, that 2 comma 9, 3 comma 8, 4 comma 7, 5 comma 6, 6 5, 7 4, 8 3 and 9 2, we have to form the 2-digit numbers that be symmetric about the center by rotating them. That is, that if let's suppose that we have 2 as the 10th digit and 9 as the unit digit, we have 29, and by swapping we have 92. On the opposite side we have 92, 9 as the 10th digit and 2 is the original digit, 92 and 29. Let's see in this table. That is 29 92, 38 83, 47 74, 65 56, then so on till 92 29. They all sum up to 121, which is actually the only perfect square which could be got, and it is 11 squared. And did you just notice that it makes perfect sense with the fact that for n is equal to 1, the sum 11n squared becomes 11 squared is equal to 121. That is, by substituting the only valid value of n, you could get it like 11 squared is equal to 121. I hope you have enjoyed the video, and also don't forget to subscribe in order to receive our upcoming amazing videos.